All right, so number one here, the correct answer is actually going to be B. Okay, so again, if you do not have B, give yourself not only an X on your learning target sheet, but put an X through the number also. And then that way you'll know exactly what you're missing, and then you can tie that with the learning target for tomorrow. You'll see. Okay? So if you missed it, make sure you're writing down, taking notes somewhere, find a spot. That's why you got to be using a different color. Okay? So first thing I'm going to do is I'm just going to rewrite the problem. Not that you had to do this, but I just want to write it down here so I can show how many steps. How many steps do I want to show on this, guys? Yep. I want to show 2 steps. So like I saw many of you doing as I look through the formatives, I see you guys putting that 1 and 2 just as I taught you, just as I showed you. Okay? We want to put them in a fraction form. Is 3/4 going to change? No, it's going to remain 3/4. Is division going to change? No. Remember, step 1 is just putting them in a fraction form, but leaving it as a division problem. Okay? Then we get over here. We do the denominator, the amount of holes it takes, or the amount of whole pieces it takes to make a whole, and we multiply it by the actual number of holes we have. Okay.
Mr. Hannah?
Okay, so remember, as I was saying, you take the amount of pieces it takes to make a whole, and you multiply it by the number of holes you have. So 5 pieces make a whole, we multiply it by 1. Then we add on the partial piece, or the partial pizza, which is just 1 slice. That means we have 6 total slices out of 5. Now, have I rewritten it as a division problem, only putting the fractions in actual fraction form? Have I done that? Yes, I have. Okay, when we do the algorithm for division, does the dividend change? Guys? No. And then division becomes?
Multiplication by the divisor number 4.
And then I do 5/6. And there we go. And then we just do top times top, bottom times bottom. We get 15/24. Now, I didn't make this an answer. I think I was meant to, but I think I meant to make that 15/24. Be prepared on the summative for me to actually make something, make it the non-simplified answer. I want you guys to simplify. Now let's go through a strategy to remember how to simplify. What's the first thing you look for when you're trying to figure out if a number is in simplest form? TJ?
If it's at the top, you look at the divisor and see if it's odd.
Yeah, well, the first thing I look at is I say, are they both even, right?
Yeah.
Don't you guys look at it like that also?
Yeah.
And if they're even, I normally just divide them by 2.
Yeah.
But when you see that one of them is odd or both of them are odd, then right away you know that the only factors you could use to divide by are 3, 5, 7, and 9, just like we did in chapter 1, finding the greatest common factor. Remember?
Yeah.
Okay, so you might just know your math facts, but if you want to use the divisibility rules, the divisibility rule again was when we add up the digits, and then we say, does that have a factor of 3? And then you do 2 plus 4. Does that have a factor of 3?
Yes.
Yes, it does. So right there, I know 3 is a factor, I know 5 isn't, but we can just go with 3 because that actually is the greatest common factor. And that's going to give you 5/8. So if you missed that, you had better, oops, that isn't going to work. You better have that written down because I want you to make sure you're getting everything right there. Okay? Everybody good? All right, number 2. Similar type of problem here, only now they're both mixed numbers. I will tell you that the correct answer is C. So go ahead and give yourself a check or an X on your learning targets for learning target number 4. And if you missed it, make sure you put an X through the actual problem also. It says it right on your test, man.
It's cut off by
4, yes, sorry. Yeah, the whole minute.
Mrs.
My
Brown,
bad.
please call the office. Mrs. Brown,
Okay,
please call the
so
office.
first thing I'm going to do is I'm going to keep it as a division problem, right everyone? Only I'm going to make these improper fractions where the number on top is larger than the number on the bottom. Okay, so that's going to become 4/3 divided by 6 times 3 is 18 plus 5 would give me 23 over 6. Now I'm ready to do step 2, which is division is just multiplication by the divisor's reciprocal. 4/3 stays as 4/3, divide becomes multiply, and 23 over 6 becomes 6 over 23. And I end up getting 24 over 69. Okay, again, I didn't make that an answer, but be prepared on the summative for one of these to be the unsimplified answer. Okay, guys? First thing you notice about 24/69, what's the first thing that jumps out at you? Ethan?
odd number.
Yep.
So you check 3, 5, 7 and 9.
You got it. Because one of them's odd, we know that that can have an even factor, right? Odd numbers can never, ever have even factors. Okay? So, we check 3. Remember the rule. 2 plus 4, that's 6. Does that have a factor of 3?
Yes.
6 plus 9 is 15. Does that have a factor of 3?
Yes.
So I know right away I can divide this by 3. And I get 8 over 23. Now again, what I noticed about this one is I said, now wait, the number 23, is that a prime number?
Yes.
Absolutely. So the only factor that I could use to divide by to help me simplify would be 23, right?
Except 8 doesn't have a factor of 20.
Exactly. 8 doesn't have a factor of 23. Therefore, what is the greatest common factor of 8 and 23? 1, right? That means 8 and 23 have a factor of 1. That's what being in simplest form means. Okay, let's go on to number 3. The correct answer is letter A. Go ahead and mark it off. If you missed it, put an X through it. Give yourself a checkered X on your learning target also. Okay, if you missed it, you better be writing down what I am. Okay, do we line up our decimals when we are doing multiplication?
No.
I see a lot of you doing this. You're saying, okay, here's 0.3, and then you take it and you line up the decimal and make it 7.0. Guys, you're wasting steps when you do that. And you're making a big mistake when you're putting the decimal back in, because you're referring to this. Okay, and I'll show you exactly what I mean. I'll do it both ways. I'll show you how it's possible. It should look like this, right, everyone? But I'll show you that both ways work, but you got to pay close attention here. This one, I lined up the decimal, which I do not want you to do. This one, I want you to do. Okay, 0 times 3 is 0, 0 times 0 is 0. I get my placeholder for that. 7 times 3 is 21, carry 2. 7 times 0 is 0, plus 2 would be 2, right? And then I add, and I get 210, right? Now look, where you guys are making your mistake is you're looking up here and saying, I mean, we all know the decimal's right there at first, right? We're doing 70 times 3. But where you guys are making the mistake is you're looking up into the original problem and you're saying, well, how many numbers to the right of the decimal do I have here? 1. So what do? You move it one place. That's wrong, right? You have to move it however many numbers to the right of the 0 that are in your actual problem. Since you added a 0.0, you got to add both those in. So now it would be 1, 2. Again, this is okay, but you better not, you got to understand that you got to look at your new problem you made, not this one. That's why it makes a lot more sense to do it this way. Never line up your decimals when you are multiplying decimals. Okay? 7 times 3 is 21. 7 times 0 is 0. Plus 2 would be 21. How many numbers to the right of the decimal did I have? 1. So therefore my decimal goes one place to that way. It's going to be 2.1. Okay? Everybody got it? Do not line up your decimals when you're doing multiplication. Okay? The next one here is going to be also learning target number 7. Okay? And the correct answer is, I think, C. Sorry. It is letter C. So go ahead and give yourself a checker and X, and also mark it wrong on a problem so that you can now write it down if you missed it. If you know you missed it, write this down so we can all get it. Okay? Again, if you're somebody that lines up the decimals, you would have had to add a 0 on there, right? But I wouldn't advise that. Remember how I told you to do this? Just make it 234 times 71. Remember that, guys?
Yeah.
Just take out the decimal. Forget about it for now. We can put it back in later. Let's just forget about it and do the problem the way we know how. Okay? 1 times 4 is 4. 1 times 3 is 3. 1 times 2 is 2, right, everyone?
Yeah.
Pretty easy one there. Put your placeholder representing that place value right there. 7 times 7 times 4 is 28. Carry your 2. 7 times 3 is 21. Plus 2 is 23. 7 times 2 is 14. Plus 2 would be 16. Okay? Now we add them together. 4 plus 0 is 4. 3 plus 8 is 11. Carry 1. 2 plus 1 is 3. Plus 3 would be 6. And then 6 plus nothing and 1 plus nothing. Okay? Now remember, we know that 234 times 71, that is definitely 16,614, right? And we know that every whole number, the decimal's after the ones place value, which is the 4 in this case. With me? Okay? So now let's put those decimals back in. Let's actually take them and put them back in. So that would be 2.34 and 7.1. Okay, so we go up here and say, okay, how many numbers did I have to the right of the decimal? I have 1, 2, 3. So I need to move my decimal. 1, 2, 3. See how I'm doing that, guys? Okay. You got to make sure you're moving your decimals right. I think that's what people are messing up. You guys know how to do the math. The problem is when you are moving your decimal, and you can see the answers are kind of set up for you to make a mistake, right? Because otherwise, if all these answers were totally ridiculous, like if this was 82.9 and this was 96.44, I mean, and you got something close to it, maybe you put your decimal there, wouldn't you just assume that C was the answer? You guys see what I mean? So the answer's got to kind of be close to one another, okay? Everybody got that though?
Yeah.
Just take out the decimal. That's your first step. Put them back in later. Okay? Let's go on number 5. Okay? Now we're doing division. This one is, the answer is B. The answer is B. So again, mark it wrong if you missed it. You got it right? Oh, by the way, you obviously also miss it if you didn't show the work that I'm showing you either, okay? On each of these problems, there's work required. Now, the problem is 0.89 divided by 0.4. Can I write that division problem as a fraction?
Yeah.
Why?
Because all fractions are division.
Because all fractions are division problems, right? What do we know about the divisor? What do we know about the divisor of every long division problem? Ethan?
That every single divisor has to be a whole number. So what you do 0.4 times 10, 100, or 1,000.
Or however many it takes. It could be times a million. Just depends on, I mean, if you had a number like this, 0.981756 as your divisor, then it would need to move 2, 3, 4, 5, 6. So you'd have to have something with 6 zeros, so that's a million, right?
It is.
100. Yeah, that's a million, yes. Okay, but because this one only needed to move one place to the right, I hope you're writing this if you missed it. Okay, if since you're moving it one place to the right, we've got to make an equivalent fraction. Or you can think of it as an equivalent division problem. Okay, so what am I actually multiplying by moving it one place to the right here? Garrett? 0.4 times 1 is 0.4. Times 10, remember? It's times 1 keeps the number the same, but then however many zeros tells you how many times to move it to the right. You with me? Okay. So then what do we got to do to the top then? Do the same thing. So what's that going to be? What's the new dividend?
8.9.
8.9. So all you did was create an equivalent fraction or an equivalent division problem. So now the new problem is this, because now the divisor's whole. So now I've got 8.9, and I'm going to divide it by 4. What do I need to do first before I really start the actual algorithm for long division? CJ?
You bring the decimal straight up.
The decimal's got to go straight up. Again, if you missed it, you'd better be writing this down. If you didn't show your work, you better be writing this down. The decimal must go straight up. Now, these numbers were pretty easy for you, weren't they? 4 goes into 8 how many times?
2.
2 times. 2 then times 4 would give you 8. Then we subtract, and we get 0. We check to make sure that's smaller than my divisor, is it?
Yes.
Absolutely. Now I'm ready to bring down my 9. Now how many times will 4 go into 9? 2, again. 2 times 4 is 8. Subtract to get 1. Can I just stop there? I see a lot of people just stopping and putting 1 right there. Can you do that?
No.
Absolutely not. Because you still have a remainder left over. You have something smaller than 4. We've got to continue to keep this long division going. Now, I want to clear up a wrong thinking. Something that you guys are all, not all, but some of you are doing wrong. I see a lot of you adding another decimal and then adding a 0. Can you have 2 decimals in one number?
No.
Never. The decimal's already there. Now, if the number was 89 and you had to add a decimal, then you would. But you're not doing anything different, right? Adding a 0 after the last number, after the decimal, to the right of the decimal, won't change the value of the number. Okay? So, we do not need that decimal there. We just simply need to add a 0. Here we go. Start the process again. 4 goes into 10. How many times?
2.
Now we're subtracting it 2. Can I stop?
No.
No, you got to bring down another 0 until that remainder is 0. 4 goes into 20 how many times?
5.
5 times. Are we finally going to get a terminating or a remainder of 0?
The Terminator.
The terminator. Okay, and there you go. So there's your work that I would need to see. I hope that helped. If you're still struggling with long division, go and review it at some point. This number 6 here is letter B. Go ahead and give yourself a check or an X. Mark it wrong if you got it wrong. I know it did. Okay. Nick, by the way, and if you didn't show your work, it's wrong. So if you just knew the answer because we did this question before, then it's wrong. You had to actually show the multiplication of decimal times decimal algorithm. Okay? All right. Nick buys 3.5 pounds of American cheese. The cheese costs $2.80 per pound. Okay? So we're looking at it going, okay, if I know how much 1 pound costs, wouldn't I multiply it to figure out how much 3.5 pounds is going to be? Okay, so this is going to be $2.80 times 3.5. Now, one quick thing. I see a lot of you doing this, which is fine. 3.5 and 3.50 is the exact same thing, right? But I beg you guys, when you're doing this, just forget about the decimals for a minute. Do 280 times 35, because you all know how to set that up. It's something about when the decimal gets in there, it messes with you a little bit. Okay? Let's do that, and then we'll put the decimal back in later. 5 times 0 is 0. 5 times 8 is 40. You're going to then carry 4. 5 times 2 is 10, plus 4 is 14. Get your placeholder. Get rid of your carries. Get rid of that place right there. 3 times 0 is 0. 3 times 8 is 24. Carry 2. 3 times 2 is 6. Plus 2 would then be 8. Right, everyone? And you get 9800. Okay, now let's put the... What?
I accidentally put a 3 instead of a 9.
I don't know. Okay, let's go up and put our decimals back in. So there I had $2.80. There I got 3.5. Now let's count up how many numbers to the right of the decimal I had. 1, 2, 3. So my decimal's right there currently, everybody, right? Would you all agree that 280 times 35 is definitely 9,800?
Yeah.
Yep, absolutely. So since there are 3 numbers up there, we need to take that decimal and we need to move it. 1, 2, 3. Now, since this is money, how many places do we actually go to? How many decimal places? Just 2. We just, what? Nope. It's the, remember, dimes, pennies.
Like 3.
Oh, yeah. But I said to the right of the decimal. Yes.
Also, none of the other answers make sense.
Yep.
Like
This one's division right here.
if you bought 3
I was about
pounds,
to say.
Exactly.
like
Yep.
280, why would you get $98?
You know what? That's a great, and I like the way he's thinking right there. He said, if you just got in a bad habit of just, since we're doing a lot of division on this chapter, and you just got in a habit of just simply dividing it, automatically dividing it, when you get an answer of $1.98 or whatever the division answer is, one of these two, wouldn't you like say, wait a minute, if 1 pound costs $2.80 and I'm buying more than 1 pound, it's going to be more than $2.80, right? Yeah.
I took off the 0 at 280.
Yeah.
Is that fine?
Yeah, just as long as you don't look up here and count your numbers to the right of the decimal up there. That's fine.
Okay.
Yeah.
I just did 2. I didn't even have the 0. I just had 2.8 times 3.5.
Yeah, that's what she
And I
did.
just lined it up.
Yeah, fine. Okay, here we go. Number 7. The correct answer is D. Give yourself a check or an X on learning target number 4, and also, if you if you missed it, put an X on the actual question number also, so that you can keep track of which ones you're missing. Okay, so I'm going to rewrite the problem in fraction form, right? Now I'm just going to simply do the algorithm. 7 over 1, divide becomes multiply. 5 over 1, I get 35 over 1, which we all know equals 35. Right? You must have that work. Okay? Next one, number 8. Again, this one's going to be D. Thank you. Okay? Okay? First step, I'm going to rewrite the problem here. You didn't have to do this, but I like to do it just so that I can see it a little bit better. Okay, dividend stays the same. Divide becomes multiply. And then we use the reciprocal of the divisor, which is 7 over 1. I get 35 over 6. Okay, now I'm ready to actually convert this into a mixed number. A lot of you are still doing this mentally. Just this is how you do it. Write this down if you're not sure how to do it, how to turn improper into mixed. If you forgot, 6 goes into 35 5 times. Then we multiply. And whatever we get as our remainder, that becomes the numerator of the partial of the mixed number. And then the denominator stays the same. Okay?
Top table, how many times?
No, at the bottom actually. Put the number you missed at the bottom. So if you missed 0 on the front, put minus 0. If you missed 1, put minus 1. If you missed 2, put minus 2. And so on. Okay, here we go. Let's keep it going here. This one, the correct answer is A. Go ahead and give yourself checker an X and also count it wrong. And yes, you need to work. Okay, after a birthday party, there are 3.5 pizzas left over. If the pizzas are divided into 1/4 size pieces, how many pieces of pizza are left over? This question is very easy because it uses the word divided. It gives you what you think of when you think of a division problem. It gives you the dividend. You with me? It gives you the dividend and then gives you the divisor, right in order. So this one should have been relatively easy for you. The problem would have been 3.5 divided by 1/4. Now remember, how many steps would I need to see this in, Ethan?
2.
I would need to see 2 steps.
First step is turning the mixed number into an improper fraction because it's basically impossible to divide a mixed number by a fraction.
You got it.
Unless you change it.
Beautiful. Yeah, dividend stays the same. Divide becomes multiply. The reciprocal of 1/4 is definitely 4 over 1. I end up getting 28 over 2. What is the greatest common factor of 28 and 2? 2, right? Because what are the only 2 factors of the number 2?
1 in it.
1 in itself. So that means that the only one that can help us simplify would be 2. And since 28 is even, we can divide it by 2, divide by 2. There's where we get 14 over 1, which we know equals 14. Okay? Let's go on to number 10. Okay, the correct answer here, helping,
C.
it is C. Go ahead and mark it wrong, mark it right. Okay? Again, if you're missing this, guys, it tells me that you got the right answer, or you got the right numbers at least. You're just messing up the decimal part. So, first step here, what did I tell you the first step to multiplying decimals is? Yep.
Turning your problem in, taking the decimal point.
Take the decimals out, guys. Every time. Don't even bother with them. Decimals make it more confusing. But it's the same process as whether it's got decimals or not, with one minor change at the end. Okay. So 9 times 5 is 45. 9 times 2 is 18, plus 4 would be 22. 9 times 3 is 27, plus 2 would be 29. And then 9 times 1 is 11. Did I get that right? Everybody had that?
Yeah.
Okay, now I'm going to get rid of my carries there. 2 times 5, oop, need my placeholder, right? To represent that place right there. 2 times 5 is 10. 2 times 2 is 4, plus 1 would be 5. 2 times 3 is 6. 2 times 1 is 2. Now I'm ready to add. When people miss these, by the way, they're missing them just because they get all sloppy with their writing. 5 plus 0 is 5. 2 plus 0 is 2. 9 plus 5 is 14. 8 and 3. Now, what is 1,325 times 29? What is 1,325 times 29? Haley? I'll ask it again. 1,325, that's what I have here, right? Times 29, what's that equal? Lily? 38,425, right? Right? Okay, we took the decimals out, right? And they're out. So we know that that is a whole number and that is a whole number is 38,425. Right, everyone? Now, the whole number 38,425, where's the decimal place? Where's the decimal go? At the very end. Every whole number's got a decimal at the end, right? We just don't go around write them. We don't say, yep, 42, period. We don't do that, but that's what it means, right? Okay, so let's go and put the decimals back in now. So here we go. That was 13.25, and that was 2.9. Or no, what? It's 29, right?
Yeah.
So we got to go and see. How many numbers to the right of the decimal did I have? I have 1, 2. So therefore my decimal needs to move 1, 2. If you didn't have that work, it's wrong. Okay, but that's what I would need to see. 384 and 25 hundredths. Yes?
Why do we put the placeholder?
This?
Yeah.
Because we're saying we're not, when we do the ones, this is just the ones place value times all the other place values. So when we're going to the tens, we got to put that in because we're done with that. So we're starting right here at the tens. We're doing the tens times all the place values. Okay? All right, next one. Very highly missed question on number 11 here. Okay? The correct answer was A. Go ahead and give yourself check or X. Yep.
I got to circle it, but I showed on my board.
Yep, fine.
This one is hard.
Okay, yes, so if you missed it, understand that you need to be writing this down. Mark it wrong. Guys, make sure if you miss it, make sure you're marking it down. Okay, you've got to do that because that's going to help you to know what the heck you missed. So you know what to practice for. Okay? First of all, let's write this fraction as a division problem. Or write the division problem as a fraction, I meant. Okay? What's the first thing you've got to notice about the algorithm for long division, Caleb? We're doing the algorithm for long division. You've got to do something before you start. You at least got to check on something. TJ?
Is the divisor a decimal?
Your divisor has to be a whole number. It can't be a partial. It can't be 5.2, 0.98, 0.16. It can't be that, can it? So the first thing that's got to happen is that thing has got to become a whole number. How can I make 0.16 a whole number, Lance?
Take away the decimal.
So, but I can't just get rid of it because that would. So what do I got to do? I can't get rid of it. I got to move it. So where do I need to move it to?
You need to move it to behind the 6.
Yep, I need to make it 16. So, now guys, we know that we're multiplying by 1 followed by so many zeros, right? Again, we're making equivalent fractions. So, 0.16, we know we're getting the same number, or at least the actual digits are the same, right? So we know it's times 1 followed by either 1 0, 2 zeros, 3 zeros, 4 zeros. How many zeros am I multiplying by then? Or how many places did I move? 2. So what am I multiplying this by? By 100, right everyone?
Mm-hmm.
Sydney with me? Huh? Because we know that every equivalent fraction has to have the same thing happening to both the top and the bottom, we must do that to the top also, right guys? This is where a lot of you made your mistake. A lot of you, as I looked through the tests and looked at your answers on the clicker, those of you that put letter D, all you did was 64 divided by 16. So basically, here's what you did. You did times 100 down here. You did times 1. Better erase that. You did times 1 up here. Is that ever going to give you an equivalent fraction?
No.
If I just take, oh yeah, I got 2/3 of pizza, and I'm going to multiply the top by 4 and say, yep, I've got 8 pieces now. Is that possible? No. You've got to do it to the bottom and say, oh, okay, I got 8/12 of the pizza. 2 different numbers, right? And that's why 8/12 simplifies to 2/3, right? It all makes sense now, doesn't it? Okay? So, we actually need to multiply this by 100, right everyone? So, what is 64 times 100? Yep.
6,400.
Yeah. Guys, look at 6 times 10 for a second. Where's the decimal in the number 6? Where's the decimal in the whole number 6? It's after the whole number, right? 6?
Right.
So if I'm multiplying by 10, that means it's going to go one place to the right. What's got to go in here?
0.
That's why 6 times 10 is 60. If I took the number 6 and multiplied it by 100, it would be 600 because the decimal's going 2 places to the right. You guys see that? If I multiply 64 times 1,000, well, that's going to be 64. The decimal's there. I need to move it 3 zeros. 1, 2, 3. 64,000. Does that make sense? I hope we're grasping this, because there's going to be one just like this on the summative. So we've got to do 64 times 100. So here we go. Decimal in 64 is right after it, and I need to move it 1, 2, right? 6,400. That's the appropriate problem. Do you guys understand that? Those of you that got D, you did not change your dividend. You can't just change the divisor without changing the dividend. Okay? So here we got 6,400. We are going to divide it by 16. 16 into 64. You might have to do some work here. You might have to go up here and say, okay, 16 times 3, 16 times 4, 16 times 5, times 5. You might have to do all that. You might have to kind of guess and check. You guys don't know your multiples of 16 very well, like you do 1 through 12, right? 16 goes into 64 4 times. Notice I put it right above the 4, right guys? 4 goes into 16, 64, or 4 times 16 would be 64. I subtract to get 0. Right? Is 0 smaller than my divisor?
Yep.
That's what we hope for, right? Okay. Now, can I just stop there?
No.
No, if you have more numbers in your dividend, you can't just stop. You've got to continue this. So you bring down, now you start the process again. How many times will 16 go into 0? 0 times. Then we multiply. Then we subtract. Then we check. Then we bring down. Do you guys understand that? You can't just stop until you've used all the digits of your dividend. Okay? 16 into 0? 0 times. 0 times 16? 0. Everybody got that? Okay.
I just had like.
You can just start grading with us right now. Get a pen out. Start grading. What?
All that because I had like this. I did this and I had an answer and then I realized it.
No, that's wrong.
was wrong.
Yeah. You got to show the whole steps here. Okay, let's go on to number 13 here. Or 12 and 13, okay? The two answers for these, pretty easy here. This will be 5 over 2. This one would be 1 over 4, because we know that every whole number is over 1. So that would be 1/4. There's really no learning target for those two. It's kind of just intertwined in there. Okay? All right, number 14, learning target number 5. This answer is it 2 2/3?
6 and 2/3.
6 2/3.
Oh my days.
Okay, 6 2/3. So go ahead and give yourself a check or an X and count it wrong or right. Okay, if you had 6 2/3. Okay, a large bottle holds 4 liters of shampoo. A family uses 3/5 of that liter each day. How many days will the shampoo last? So guys, this is obviously a division problem. Is the 3/5 liter being divided, or is the 4 liters being divided?
4 liters.
The 4 liters. Again, if you missed this, you had better be writing this down. So it's 4 liters divided by my 3/5. The 3/5 liters is just the group size, or the amount that's used each day. Right, everyone? All right, so let's make this in fraction form. Now we just do the algorithm. 4 over 1, divide becomes multiply, and then we can do 5 over 3, and we get 20 over 3. When we do the thing to turn it into a mixed number, 3 goes into 26 times. We get a remainder of 2, 6 and 2/3. There's the work I would need to see. Everybody got that?
I mixed them up. I did 3/5.
Yep. You could. Yep. And that's where you got to think. Remind yourself. Dividend. You've got to identify the dividend. What's being divided up? Yeah. If you model, that's fine. That's fine. But you should always write the division problem. Let's go to number 16.
Mr. Garris.
Yeah.
When I did it, I divided the 3 by 20 and stuff, but I just put 5 there instead of 3.
Okay.
I forgot that was 3.
That's fine. Okay. Lisa had 2/3 of a pie left over from lunch.
Wait, what was that?
It's right on your paper, dude. Okay. She cut it into pieces, each of which was 2/9 of the original. So, guys, I had a lot of questions on this throughout the day, I thought. And my question to all of you would be, what's being divided? What's being cut up here? Is it the 2/9 pieces, or is it the 2/3 that was left over? Yep. The 2/3 that was left over is your dividend. That's what's actually being divided. Okay? So, you got to model it, obviously. It says model right there. If you didn't model it, it's wrong. What was the correct answer? Is it 3/20?
It's 3.
It's 3, by the way, so you should be writing this if you didn't get 3. So mark that wrong if you didn't have it.
So it says it's 5 and 3.
Put a check and an X on both of them. Because 5 is the story problem, 3 would be the modeling. So I guess if you missed the modeling, make a note. If you missed the story problem, it's 3 or 5. So I don't know. It's kind of both. Okay. So I have my whole drawn here. I've got to model my dividend right there. So that's going to be cut into thirds, right, everyone? Okay. So there's 1 and 2. Okay. Now the question here would be, how many groups of 2/9 are there in 2/3, right, everyone? Okay. So we've got to figure out how to cut this thing into 9ths. Lily? You cut each third into 3 pieces. Because now we can actually answer the question. Because again, we are looking for groups of 2/9, right everyone? So that means 2 1/9 sections makes a group. So here we go. I have 1/9, 2/9. What's that represent? One group. I have 1/9, 2/9. That one group. 1/9, 2/9. One group. Do I do anything with this? No, because you never had it. That part of the pie was gone. Okay? So that means that how many pieces? There were 3 pieces she could make. So basically she could give it to 3 people. Okay? Everybody got that? So you must have the model. Should we check with the algorithm? Absolutely. A lot of you still are not doing this, and I have no idea why. 2/3 times 9/2 would give you 18/6. The GCF of those is definitely 6, which gives you 3/1. Okay? At the bottom, put how many you missed on this page. Let's go.
Mr. Garrison,
What? What?
Is it okay that I just divided, like, I did how many times is 6 go to 18 and then 3?
It's fine. Okay, so, yes. It's okay. You should have. It's alright, it's not wrong. Alright, a baker uses 6 total teaspoons of salt to make dinner rolls each day. She uses 3/8 of the salt for each roll that she makes. How many dinner rolls does she make? Guys, what's being divided up here? Is it the 6 total teaspoons, or is it the 3/8 teaspoon for each roll? Yeah. Yeah, the 6. We're talking about we have a total of 6, a whole amount. So here we got 6/1 divided by 3/8. Now over here, I'll do the algorithm. If you did that, you could have used either method. What? Oh, answer, yeah. It is 16. Sorry, I forgot. 16. 16, right everyone? 16. Right? Yep.
Do we have to model it?
You could do either one. So now over here we end up getting 48/3. The greatest common factor of 48 and 3 is definitely 3. And I knew that because 4 plus 8 is 12. And 12 has a factor of 3. And I get 16/1. If you modeled it, it would probably look something like this, where you went 1, 2, 3, 4, 5, and 6. Yeah, they should be. Oh my gosh. Okay, these should be cut into 8ths. Oh boy. I think you guys would know how to do it.
Yeah.
And then you know that if you did it cut them all into 8ths, then you would go 1, 2, 3. That represents a group. And you'd have 16 of those 3/8 groups. Okay? So I'm not going to finish it because I think you guys got it.
And it's way too small.
Yeah. 17. The correct answer is 3/40. Everybody missed it. Pretty much everybody, but about 3 or 4 people in every class missed this question. So I want to take some time on it, so please listen. It's 3/40, right?
Yeah, I know that. Oh, because
All right.
you had
Shh.
3.
Yep. Now watch. Listen, this is important. We're going to put one just like this on the summative. Kate and Dal had a pajama party with 4 football teammates. The 5 of them, right, because guys, please listen. This is the hardest question on the test, and literally, I would say 8 or 9 people got it right all day in all my classes. 8 or 9. So if you're one of those, good job. Maybe it was more like 15 or 16, but still, about 15% of people got it right. That's a problem. The 5 of them ordered 1 extra large pizza. So, okay, so we know there's 5 of them because it's Hayden and his 4 friends, right? So there's 5 of them.
I didn't help you.
I should see everybody's eyes up here, please. There are 5 of them. Okay? They ate 5/8 of the pizza before the pajama dance-off. Okay? Then the next morning they ate the leftover pizza. How much pizza would each of them eat if they all got an equal amount? And people were confused here. They were saying, well, this is the amount. Are we dividing this by 5 or are we dividing 3/8 by 5? It's about the leftover amount. How much of the leftover pizza did they get? We know if they ate 5/8 of the pizza last night, how much is remaining the next morning? 3/8. Most pizzas are cut into 8 slices, right?
Yeah.
Usually anyway. If they eat 5 of them, then we know 3 are remaining, right? So, that means that this problem is actually 3/8, and we are dividing that by the 5 people, Caden and his 4 friends. Because that's how much pizza is remaining. Right, everyone? Now we've got to model, because it says model. So we got to model the dividend first. So we got to model 3/8. So here we go. 1, 2, 3, 4, 5, 6, 7, and 8. We need to shade 3 of them, right? Uh-oh. Shade 3 of them. So 1, 2. That's how much they have. Now we get out our knife and we cut it horizontally, right? By the 5 friends. 1, 2, 3, 4, 5. Right, everyone? And then we want to know how much pizza each one of them would get. 1, 2, 3 slices, so they all got 3 pieces. And then how many total slices were there in the entire pizza? 40. 5 rows of 8 columns would be 3/40. To check with the algorithm, it would look like this. 3/8 times 1/5, which would give us 3/40. Does everybody understand that question now a little bit better? Okay. There'll be one just like it on the summative, so be prepared. Okay, draw a visual model here. Okay, I got to model my dividend first of all, right? The answer is, help me, 9. Okay, so I model my dividend first of all. There we go. There we go. Now, since the question would be how many groups of 2/3 are there in 6, we're going to cut this into thirds. Cut it into thirds. Cut it into thirds. Cut it into thirds. Cut it into thirds. Okay? So, we know that 2 of them make a group. So 1, 2. What's that represent? What's that represent? 1 group of 2/3. Here we got 1, 2. What's that represent?
1 group.
1 group. 1, 2. 1 group. 1, 2. 1 group. 1, 2. There's 1 group of 2/3. 1, 2. 1 group. 1, 2. 1 group. 1, 2. 1 group. 1, 2. 1 group. And we know there are 1, 2, 3, 4, 5, 6, 7, 8, 9 groups of 2/3 in 6. Now we need to do the algorithm. 6 over 1 times, I'll just do it from up here. Shh. Be quiet, please. 3 over 2 would be 18 over 2, which is 9. Right, everyone? Okay, so you must have the model. Hopefully you got that down. Okay, 3/4 divided by 5. Start with modeling the dividend, right? The 3/4. So 1, 2. Oh, it is 3/20. Sorry. Okay, so you know whether to write it down if you missed it. Why are you grading in pencil right now, Lauren? Okay, I got to model 3 of them, right? 3/4. Now I'm going to divide by 5. Okay, now remember, each row is representing how much a friend's going to get of this cake or whatever. Right, everyone? Each friend's getting that amount. We know that each friend's getting 3 out of how many total pieces? 4 columns of 5 rows is 20. Do the algorithm to check. 3/4 times 1/5 gives you 3/20
Is
also.
it wrong to forget the algorithm?
No, but you should do it.
I just forgot it this one time.
Okay, here we go. Model the dividend. Remember, when I do the fraction by fraction, I like to draw it as a skinny box that's longer. You don't have to, that doesn't matter. But it just helps you to cut it up. Oh, the answer is 24/6.
Six.
I was doing the problem in my
I
head.
was like,
All right, it is 6. Okay, so if you didn't get it right, make sure you're writing this down. We cut it into fourths. We need to shade 3 of the 4. Okay, and we then need to take the knife out. And we need to say, well, if we want to know how many groups of 1/8 there are, I need to cut each fourth in half, right, Lance? Huh? Okay, so then there's an 1/8. That's one group. There's an 1/8.
Teacher, please hold.
Another 1/8. Another 1/8. Another 1/8. How many groups of 1/8 do I have? I have 6 groups. So dividend stays the same. Multiply by the divisor's reciprocal. 24 over 6. That definitely, 24 over 4 equals 6. Okay, number 21, the correct answer is 52.13. Okay, so if you didn't get that right, make sure you write this down. When you're doing, listen, when you're doing addition or subtraction, you must line up the decimals. So I look here and say, okay, there's my decimal right there. What's in the ones place there? Well, it's a 2. So then I can add a 5 there and make it 1. Now what can you add in to fill in these empty spots? Zeros if you want to. Doesn't change the value. 3 plus 0 is 3. 1 plus 0 is 1. My decimal comes straight down. 0 plus 2 is 2. 0 plus 5 is 5. Everybody got that?
Yes, you did add a 3 on the end.
You got it, but you had to show this work right here. If you didn't, it's wrong. Okay, here, adding again, 3.25.
answer.
It is
4.05.
4.05. Okay. Now, since I'm doing 0.8, my decimal's got to stay there, and so 0.8 would go right there. What can I put in all these spots? Zeros. 5 plus 0 is 5. 2 plus 8 is 10. Bring your decimal straight down, and I get 4.05. Everybody got that? Put the number you missed on that page, please.
We didn't do that on the last page.
Yeah, we did. You just didn't hear me. All right, here we go. The correct answer here would be 44.3. Right? 34.3. Sorry. So here we go.
34.3.
Not 5. That's it.
Okay. 56.3 minus 22. Again, lining up your place values. 3 minus 0 is 3. Bring your decimal straight down. 6 minus 2 is 4. 5 minus 2 is 3.
Oh, crap.
Okay. Next one. The correct answer is, help me.
18.64. 0.6. I got 0.69. It should be 0.69.
18.64.
Oh.
18.64.
Yeah, it's 18.64.
Oh.
Okay, so here we go, 24.54. Again, all the place values must be lined up, so when I'm bringing this one down, I bring my decimal straight down. 5 would be there, 9 would be there. I can put zeros in these other spots. Doesn't change the value. 4 minus 0 is 4. Now we've got to borrow a dollar bill turned into 10 dimes. Oh boy. And then add it to my 5 that I had. 15 minus 9 is 6. Bring the decimal straight down. Got to borrow a $10 bill. It's going to be 1864.
Copied it down.
Everybody got it?
25.
That's 58.
Come back. Okay, so we're going to start with the subtraction problem here. The correct answer here is 34.3. Okay, so if you missed it, you better be writing something down. Okay? So when we're doing subtraction, do we line up our place values? Yeah, so you always start with 56.3, and then you just put your decimal straight down. Well, where's 22 going to be? Just to the left of that, right? Can I put something here to help me fill this in? Yeah, isn't 22 the same as 22.0?
Yes.
All right, 3 minus 0 is definitely 3. 6 minus 2 is 4. 5 minus 2 is 3. What should I do with my decimal? Bring it straight down. 34.3. You must have that work to get it correct. Give yourself a checker next on your learning targets also. Yep. It's all right. It happens. Okay, here we go. Next one, we got 24 and 54 hundredths, and we're subtracting 5.9. So I always like to put the decimal there so it helps me remember. 5.9, and we can put our 0 in there. Okay, bring our decimal straight down. 4 minus 0 is 4. Now I like to think about money when I'm doing this. I can't take 9 dimes from 5 dimes, right? So I've got to go over and I got to borrow a dollar bill. I'm going to turn that $1 bill that I borrowed into 10 pennies. Now I've got turn that $1 bill into 10 dimes. Add it to my 5 that I already had. Now I have 15 dimes, right? 15 minus 9 is 6. $3, can't take 5 from it, right? So I go over and borrow a $10 bill. I turn that $10 bill into 13 $1 bills. 13 minus 5 is 8. 18 and 64 cents. Or 18 and 64 hundredths. Everybody got it?
Dude.
All right. Number 25. Okay. There was some confusion about this one last period. People were arguing with me about the answer for some reason. So let's do it now. First of all, whenever you're doing long division, what's the first thing you need to check for? You got to make sure of, Luke. Okay. Katie? Your divisor has to be a whole number, right, everybody?
Yep.
Is it? So we're good to go. There isn't any work we had to do here as far as moving the decimal place or anything. So we're ready to just go ahead. 1,455 divided by 25. Oh, I will. Have percent. Put kg on 6th grade, please. And 5th. Kg on 5th and 6th. Okay, here we go. Thank you. Oh my gosh. All right. Bye, Jaylene. Okay. 25, can that go into 1, guys? 25 into 14. 25 into 145.
Yes.
Now, maybe you knew, well, I know 25 goes into 150 6 times. Maybe you use that rationale possibly, or maybe you just count it by 25. 25, 50, 75, 100, 125 would be 5 times. Multiply that around to get 125. Then you subtract to get 20. What do I do at this step right here? Who remembers? What do I do right here with that number? Go ahead, Evan.
Oh, you gotta see if it 25 can be divided. See if you can divide 25.
Well, hang on. No. You're a step ahead of me. First thing we've got to do is we make sure that's smaller than my divisor, right? Then we have to bring down the next number. Now we do, how many times will 200 or 25 go into 205? Now I know 25 goes into 100 4 times, right? So that means 200 how many times? 8. Now I get 58. So then I multiply and I get 200. Now in elementary school, what would the answer be? Remainder 5. But we don't do remainders anymore. We turn those remainders actually into decimal places. We actually find the decimal answer. Okay? So what do I got to do here? I got to have something to bring down, but I can't just add a 4 there and say, yep, I'm just going to bring down a 4. What can I do? Lorette? I've got to add a decimal. Now, the key isn't about adding the decimal there. What's important about adding a decimal? Brooke?
To make sure that the value of
Right, but if my decimal...
Oh, you have to bring it up.
You got to do it straight up. It really doesn't matter in the algorithm, doing the algorithm here. You don't have to have the decimal here. All the decimal does is tell us where it goes there, right? So now I'm going to add a 0. Did I change the value of my dividend?
No.
No, I did not. And 25 goes into 52 times. Now I've got 50. Subtract to get 0. Okay? Is everybody good with that? You had to have that work. If you didn't have that work, it's wrong. Yep. Yes. 6. It's supposed to be a 6. Yeah, I just... Sorry. I know it's all sloppy looking. Yes. You're fine. All right. Here we go. Let's go to the next one. Number 26. Okay. A coffee shop worker is putting 18.125 pounds of coffee into 0.25 pound bags. How many small bags of coffee can the worker make? Now, this is no different than the modeling division, isn't it? Of fractions. Only instead of fractions, they are decimals, correct? But isn't it the same thing? you're taking a whole amount, you're dividing it up or cutting it up or grouping it up or putting it into bags. Isn't that a typical division problem, guys? So the problem is 18 and 125 thousandths divided by 25 hundredths. So what's the first thing we've got to make sure of, though? Got to make sure we do this. Jason? That divisor must become a whole number. How can I do that? And there's a lot of ways to do it, but what's the easiest way? Jace?
Move your decimal over twice.
Move your decimal there, right? So let's remember it like this, though. I just want to make sure we're all understanding this. All fractions are division problems, right, guys?
Yeah.
So doesn't that mean that all division problems are also fractions? You got it. So if we make that 25, what am I multiplying by to go from 0.25 to 25? Annalise? I'm multiplying by 100. So if I do that to the bottom, what must I do to the top? Which means moving it to the left or to the right twice because there are two zeros. 18, 1812.5. Everybody got that?
Yep.
So I moved it twice there, I moved it twice there. Now I'm ready to do the problem. So here we go. It's here, 0.5, 0.25. I've made sure my divisor is a whole number and all that. What's the next step do I do? Whoa, I mean to do that. What's the next step that I need to do right here? What's the next step, Luke? Nope, not yet. You're skipping one very, very important step. Erin? No.
Can go into one.
Nope, you're one step ahead of me. Don't skip the most important step here. Let's go, Aiden. Move your decimal straight up so you don't forget. Because that's the biggest thing. A lot of you know how to do long division. Your decimal's just in the wrong spot on a lot of these. 25 will go into 1 0 times. 25 into 18 0 times. 25 into 181, how many times? 7. Okay, and that's going to be 175. I subtracting at 6. Now, Evan, remember I make sure that that's smaller than that, right? Now I'm ready to bring down a 2. 25 will go into 62 how many times?
2.
It'll go in 2 times. So then I multiply, subtract, and I get 12. By the way, I don't know why this is. It's not really funny, but it happened a lot. I saw a lot of people's papers. You guys were just leaving that one off. It's like you did 2 minus 0 and left it as 2. So those of you that have 72.1, do you see your mistake? It's not, this difference isn't 25, it's 125. You didn't subtract right. 62 minus 50 is 12. You guys see that?
Yeah.
Now 25 goes into that 5 times. I multiply it around to get 125, and we get our remainder of 0, which is what we want. Everybody see it and got it? Okay. Next 3, pretty much everybody did well on these, except one person that's probably very, very mad at themselves. Huh? Yeah. Yeah. Okay, quotient is the answer to a division problem, so that's 8/9. The dividend then is the first number, which is 2/3, and the divisor is the second number, which is 3/4.
Thought we weren't supposed to remember it that way. Who cares?
Yeah, I'm just saying. All right, now, shh. No learning targets for that one.
Yeah.
Okay, number 30. This is just using the words dividend, divisor, reciprocal, state the algorithm. If you didn't use the word dividend, that's okay. I wanted you just to say what I've been saying over and over. Division is just multiplication by the divisor's reciprocal. But if you wanted to use dividend, you would have said it like this. Division is just multiplying the dividend by the divisor's reciprocal. It's the same thing.
I didn't get what you were trying to say.
Yep.
I said that, but I like
Either. And then, guys, an algorithm, very simply, is a what, Aiden?
21.
Just a step-by-step process or a set of steps to find an answer or whatever. Yeah.
I said it's a step-by-step process of finding the answer.
Yep, fine. As long as you said something about it being a step-by-step process.